Hello, Year 8. I'm going to talk to you about metals and oxygen and metals with water today. So I'd just like to begin with looking at these two photos here of two bikes. Which bike would you prefer? What happened to the first bike? Can you explain scientifically? So you can see there's very obvious differences just by looking at the two images of the two bikes. What has happened to the one on the left? Why has it gone that colour? Why has it rusted? Okay, you need to think about the reaction that's happened there. So this is firstly talking about reactions of metals with oxygen and a little bit of water as well, but mainly oxygen we're going to talk about in this case. So obviously, without a shadow of a doubt, you're going to prefer the bike on the right. It looks new, it's not rusted, a number of reasons, and just generally looks better. So this is what we're going to be looking at today. Metals reacting with oxygen and water. So compare the reactions of different metals with oxygen and water and use state symbols in balanced formula equations. Those are your two learning objectives for today. We've already talked about the bike. We're going to talk a little bit more about rusting and why the bike has gone that colour. And the picture on the right is of reactions with water and the group 1 metals there. So you've got Li, which hopefully you'll be able to identify some of these already, Li, lithium, etc. Okay. So just looking back at the bikes, what is formed is something called iron oxide, and that is when ions, the bike made of iron, okay, the metal, reacts with oxygen to form something called iron oxide, and that's what gives it that rusty looking reddy colour. So the bike on the left has rust. The bike is made from iron, and when it reacts with oxygen and water, it produces a covering of iron oxide, which is a reddy brown, orangey sort of colour. A lot of bikes are made of different materials these days, so they won't rust as easily when they're left out. A bit more hard wearing. So this is what happens as another example, this time looking at magnesium, when you burn magnesium with oxygen. Okay, so there's magnesium ribbon there. Okay, you react it with oxygen, this is just oxygen in a canister here, and you form something called magnesium oxide. If you haven't noticed already, when a metal reacts with oxygen, it forms an oxide. These are your reactants, so these are before the arrow, before the reactions happened. And the product is magnesium oxide in this case. Magnesium and oxygen together form magnesium oxide, and this is shown as a powder format here. So these group 1 metals with oxygen, let's have a look at a few others. Group 1 is found on the left-hand side of the periodic table at the beginning. And these have to be kept in oil, so they don't react with oxygen and water because they're so reactive. If they're exposed to oxygen, so just in the air, or exposed to water, they react quite quickly, and depending on where they're positioned in the periodic table. So they have to be kept under oil, and that kind of just stops them reacting with anything. When we cut them, they're shiny, so if you've done this in class, you can cut them like butter. They're not necessarily hard just because they're metals. However, as they begin to react with oxygen in the air, they turn dull, so they lose their shiny coating, forming a metal oxide. So when you cut them freshly, they're nice and shiny. So here's one example for you. So a metal plus oxygen is metal oxide, so that's your word equation there. So replacing that, you can use lithium as your metal, plus oxygen gives you lithium oxide. So as I've told you, when you react a metal with oxygen, it forms an oxide, in this case lithium oxide, as the metal is lithium. Just below that word equation, we've got a symbol equation. These symbols are from the periodic table, so lithium is Li, plus oxygen, O2. There are reactants to produce lithium oxide, which is written as Li2O. Don't worry about this too much, just learn to start to understand how we form symbol equations, okay? They end up having to be balanced, but that's a little bit beyond what we need to know right now. We can also react them with oxygen by burning them, and they form lovely colourful flames like so. So here's some examples for you. Lithium, lovely red. We've got potassium here, one of my personal favourites, a lovely purple colour. We've got a few other colours here as well, orangey red, orangey green, and another sort of red as well. Okay. Copper and sodium, so sodium Na, copper as well. So what I'd normally ask you to do is predict, make a hypothesis of what you think is going to happen if we were doing this in the lab. So we're just going to talk about it, and then we're going to have to do a little bit of research. So it says, what is the product when a metal reacts with oxygen? So you know you form something with oxide in it, I've just told you. Prediction, predict the product of the reaction between magnesium and oxygen. Well, we've all talked about that once, so hopefully you'll be able to tell me it's magnesium oxide. So this is what you would do as a method. So you would collect the sample. So I'd set out some metals around the lab with a pair of tongs. Then you would, with the tongs and each sample, heat a blue flame with your Bunsen burner for 30 seconds to a minute and record what you see. Record your observations in a results table like we normally do. Then you would write an equation to represent what reactions you've seen and even including state symbols. So whether it's a solid, liquid or gas. So we're going to have a look at what you would have found and do a little bit of research. So this is what I would like you to have a go at doing. So you've got your metal column, your speed of reaction and the observation of the product, so what you actually produce. So this is something you're going to have to go away and research in a second. So I'm just going to explain the table first. So you've got magnesium, iron, copper and calcium as the chosen metals that I've asked you to research. Then speed of reaction, so how quickly does the reaction happen with magnesium, iron, copper and calcium? They're all going to react at different speeds and different intensities. You need to write whether they have a fast reaction, a vigorous reaction, more of a slow reaction, depending on which metal you're looking up. Observation of the product, so what does it look like? So what would you see? So maybe have a look at some videos or look at some diagrams, some photos of what you have seen with each of these metals. So I'd like you to pause the video and do some research and then send this to your science teacher with your answers. So this simple, just draw out the simple table in Word or by hand, find out the answers and then send them to your teacher. I'd also like you to have a go at these questions. So once you've done your research, you will know a little bit about these metals from the table. And here are your 4 questions. Which metal is the most reactive? Which metal is the least reactive? What new products have you made? What factors may affect the results in your investigation? Okay, so there's your questions I'd like you to have a think about and also send those to your science teacher. So let's have a little look at some word equations then. So what would happen if you'd react magnesium, okay, with oxygen, iron with oxygen, copper with oxygen and calcium with oxygen? So using the same metals that I've given you in the table, can you have a go at writing some word equations as well? So these are reactants that I just explained, okay? Have a go at that, pause the video and then come back and have a look at the answers. So here is what we would form. So we would form magnesium oxide, iron plus oxygen is iron oxide, copper plus oxygen is copper oxide, and calcium and oxygen is calcium oxide. So it's a real easy trend that you can see happening here. You know it's reacting with oxygen, so you know you're going to form an oxide product. It changes depending on which metal you are reacting with the oxygen. Just to make it a little bit trickier, we're going to write the symbol equations with states of matter. So whether it's a gas, whether it's aqueous, so dissolved in water, liquid or solid, have a go at researching whether, using state symbols, what magnesium and oxygen to form magnesium oxide would look like using the symbols from the periodic table. And are these in a gas, aqueous, liquid or solid state as well? So pause the video and have a go at doing that now. So this is what hopefully you would have researched even if you did a couple. Don't worry about the numbers in front too much. These are just making it balanced. We'll come on to this next year. You've got magnesium, which is Mg, and that's a solid magnesium ribbon. So you hold it's a solid, and we've got our oxygen gas, of course, G. Magnesium oxide is a solid still, solid powder sometimes. Iron is Fe plus oxygen O2 gives us iron oxide, so Fe2O3. Again, this is just balancing. So just understanding the symbols and how to use them is what you need to know right now. That's a solid as well. All the products are solid. I've got the S's. Copper is Cu, oxygen, O2, copper oxide, CuO. And then we've got calcium, which is represented by Ca plus oxygen, O2, which is CaO. Balance with the 2 there, don't worry about that. Okay, that's having a look at metals and oxygen. So I'm just going to give you a couple of true or false. So I'd just like you to think in your head as I talk about each statement whether you think it's true or false, and I'll show you the answer straight away. So metals combine with oxygen to form metal oxides. True or false? Metals combine with oxygen to form metal oxides. Hopefully you're thinking in your head straight away, that's true. That's what we've just been talking about. Some metals will not react with oxygen. So do you think all metals react with oxygen, or is there going to be some that will not react? And hopefully you're thinking true. Some metals won't react at all. Magnesium is less reactive than copper. It's meant to say than copper. Which one's more reactive? It's not. Magnesium is definitely more reactive than copper. All metals rust in air. No, they don't. Not all metals react and form rust. Water is also formed when metals react with oxygen to form metal oxides. Not at all. We haven't mentioned water in any of our word equations or symbol equations. It's simply metals with oxygen form metal oxides. Nothing to do with water in this case. Air is a mixture containing oxygen. Yes, of course it is. Air is a mixture. It has oxygen in it. It has carbon dioxide. It has other gases like nitrogen as well. We've just been talking about oxygen gas though. All metals have to be heated before they will react with oxygen. No, they don't. If you think about it, we didn't heat the bike up. It was just left outside and reacted to form iron oxide. Okay, just going to have a little look at metals with water now. So we're leaving oxygen and we're having a look at water. So looking at the metals, the group 1 metals with water now. So just have a look at the position of where these group 1 metals are. So they're highlighted on the left there. So we've got lithium, sodium, potassium, and then moving down rubidium, cesium, francium. So we don't really deal with the lower 3. They're very reactive. You'll hopefully know about lithium, sodium, potassium. They're used more frequently and at school. So a little bit of a prediction then. So metals with water. So how do the group 1 metals react with water? So how do you think they're going to react depending on where they are in the periodic table? I've kind of already helped you a little bit. So do you think lithium is going to react more vigorously than francium, for example? What does the reaction produce? So what do you think the reaction produces? So we've talked about metals and oxygen forming a metal oxide. What do you think metals and water are going to form? Number 3, why are group 1 metals stored under oil? So if you remember back to what I said at the beginning, why are they stored under oil and not just left out in the open? What happens to the reactivity as you go down the group? So again, I've given you some help with that. Do you think the metals become more or less reactive as you go down group 1? And lastly, 5, why do you think they are also known as alkali metals? So just why do you think that is? Okay, so I'd like you to just pause the video, have a go at that, and I'm just going to go over the answers with you straight away. Okay, so number 1, how do the group 1 metals react with water? So lithium, sodium, potassium all react vigorously with water. They're all very reactive. Vigorously means they react with energy. There's quite a vigorous reaction, a big reaction. What does the reaction produce? So hydrogen gas bubbles off, a metal hydroxide is formed, which is a strong alkali. So we've got a metal hydroxide this time, not a metal oxide, a metal hydroxide. So metal and water forms a metal hydroxide. Why are group 1 metals stored in oil? So that prevents them reacting with the oxygen and water vapour in the air. What happens? The reactivity as you go down the group. the reactivity of the group 1 metals increases, so it gets greater as you go down the group, and that's to do with energy shells. So the electron is further from the centre, from the nucleus, so there's more vigorous reactions. Why are they called alkali metals? They form an alkali solution when in water. So they form, if you think about the pH scale, form alkali, so anything above pH 7, which is neutral. Anything below pH 7 is acidic. So I'm just going to show you a little clip here. Some of you would have seen this. If you were with me, you would have done, but if you haven't, this is reactions of group 1 metals with Richard Hammond. So I'm just going to show you now.
Whether you've left school or you're still at school, you can appreciate the sheer fun and mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now, you may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O with sodium. And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, mate, present. These next two are the dog's nuts of the periodic table. They are, if you like, the king and queen of alkali metals. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay.
Good luck. Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody. This one's going to be bad.
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes!
Wow.
That is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There is one more alkali metal we can legally use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty, could go off at any time.
And that's it.
Oh, yes.
Brilliant. I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave you to it. Good luck.
Thank you.
Okay, John. Go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does. Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason they wouldn't let us have any of that. Still, there you go. Today's lesson.
Never mixed alkali metals with water.
Okay, so I hope you enjoyed that video. That just shows the reactions of metals with water. Francium, obviously not allowed. It's that reactive. You can't even get it legally. So, yeah, very reactive metals indeed. Let's have a look at what's happening then when you react these metals with water in word and symbol equations. So when group 1 metals react with water, they produce hydrogen gas and a metal hydroxide. So we're producing 2 products this time compared to 1 product with the reactions with oxygen. So here's our example lithium, our group 1 metal with water. There are reactants, and we form lithium hydroxide and hydrogen. Just looking at the symbol equation there, lithium Li plus water H2O gives us lithium hydroxide. Hydroxide is OH. Okay, lithium hydroxide, OH, plus hydrogen, which is H2. Okay, I'd like to have a go at some others just for practice. So pick a different group 1 metal and write the symbol and word equation for it. So pause the video now and have a go at that. Okay, you could have come up with other examples. I'm just going to talk to you about some. So you could have done, let's have a look back at our periodic table. So you could have done sodium. So sodium plus water would have formed sodium hydroxide plus hydrogen as one example. And you could have used potassium, K. Potassium plus water, potassium hydroxide plus hydrogen. So the only thing that changes is the metal. The products hydroxide and hydrogen stay the same. Okay, so that's it for today. So we've looked at metals and oxygen and metals with water. Place a tick if you have. So if you hopefully have achieved the LO, you would have ticked it. If you haven't, hopefully next time we cover this, you will do. Maybe a little bit unsure on some things. That's it. Thank you very much.